I'm going to be talking about factoring polynomials. This is Chapter 5, Section 4. Most of this should be a review. Some of it is a little bit new to you. So the first one, let's just practice factoring completely. So the first thing we have to do is there anything that we can factor out of both of them? Is there a common monomial that we can factor out? For number 1, the common monomial is x. So we can make this x times x squared minus 4x minus 5. And then we have to look inside at this trinomial to see if we can factor it, which we can. So this turns into x times x minus 5 times x plus 1. There's nothing else that we can factor, so we are finished. This second one, we can take out a 3y cubed, and this becomes y squared minus 16. Now, y squared minus 16 is the difference of two squares. And the difference of two squares has a certain pattern. And that pattern is we take the square root of both and we do y plus 4 and y minus 4. And so that is complete. You'll see the difference of two squares showing up a lot. So you have to be able to recognize that pattern. For number 3, we can take out a 5z squared. And that becomes z squared plus 6z plus 9. This can be factored to become z plus 3 and z plus 3. And we can simplify that saying 5z squared times z plus 3 squared. And we have factored that completely. So a little review for that. Next up, we have the sum of two cubes and the difference of two cubes. So this is another pattern, just like the difference of two squares, that we have to remember. So the sum of two cubes says if we have an a cubed plus a b cubed, we can factor it to be a plus b times a squared minus ab plus b squared. So let's practice on 64x cubed plus 1. What I like to write down to help me is what a is. So the cube root of 64 for this one is 4, and the cube root of x cubed is x, and our b value, the cube root of 1, is 1. And so now we can plug it in to this formula, into this pattern. So a is 4x plus b is 1. A squared is 16x squared. A times b is a negative 4x. And then b squared is 1. And we've got our answer for that one. Difference of two cubes is very similar. It's another pattern. If we have a cubed minus b cubed, we do a minus b times a squared plus ab plus b squared. Same thing for this one. I write down my a. The cube root of 27 is 3. Cube root of x cubed is x. And our b value, cube root of 8, is 2. So we're going to plug it into this pattern. So we have 3x minus 2. A squared is 9x squared plus 3x times 2, which is 6x, plus b squared, which is 4. So we can use this pattern to factor quite easily the difference or sum of two cubes. So we're going to practice a few more of these. We have x cubed minus 125. Our a value is x. Our b value is 5. So that's the difference of two cubes. So we're going to apply that pattern. So we get x minus 5 times x squared plus 5x plus 25. And we've got our answer. For number 2, we don't have any cubes here, but we can factor out a monomial first. We can factor out a 2s squared, and we get 8s cubed plus 27. And now inside the parentheses, we do have the sum of two cubes. And the sum of two cubes for that, our a is going to be 2s, and our b is going to be 3. So now what we have is 2s squared, and then we apply our pattern to the one inside the parentheses. So this is going to be 2s plus 3 times 4s squared minus 6s plus 9. So sometimes you do have to still remember to factor out a common monomial if you're not seeing the sum or difference of two cubes. So it's always good to look for that. Next up, we have factor by grouping. So if we have four terms, we can group two terms together, factor those out, and then combine again. I'm going to try and factor these two to see if they work. So out of x cubed plus 3x squared, we can factor out a common monomial, which is x squared, and we get x plus 3. Out of the second one, I'm going to factor out a negative 7, and I get x plus 3. If we have the same factor here and here, it's like a backwards distribution, and we can pull out the x plus 3 and multiply it by these two terms, x squared minus 7. So it's kind of a trick we can do with factor by grouping for that one. And that's our fully factored one right there. Now sometimes it's not always in the same order. I picked the first two, it worked. Well, I picked the first two and it didn't work, so I have to try some different things. So what I tried next is I wrote it as z to the fourth minus 27z minus 2z cubed plus 54. I rearranged it to see if that worked for me. And then I grouped these two and those two together. And then I factored out a z out of this one, so I got z cubed minus 27. And then from this one, I factored out a 2, and I got z cubed minus 27. So sometimes you have to rearrange these terms and just try to factor out your common monomial. And whenever you get those same two factors, then you can group them together. So we can say z cubed minus 27 times z minus 2. Well, if we notice, z cubed minus 27 is the difference of two cubes, so we can factor out using that difference of two cubes pattern to be 3a. Oh, sorry. We can factor it out as z minus 3. Let me fix that. Times z squared plus 3z plus 9, and then we put our z minus 2 at the very end. So you have to make sure it's completely factored for those. Okay, so that's factor by grouping. I have one more way to factor for you. We can factor out polynomials in quadratic form, meaning we can rewrite these as squares, okay? So 16x to the fourth, if we rewrite it as a square, we can make it 4x squared minus 9 squared. This way we have the difference of two squares, and we can use that pattern for difference of two squares to factor this out. So this would be 4x squared plus 9 and 4x squared minus 9. Once we do that, we have to see if we have any other difference of two squares. This last one is a difference of two squares, so we can factor this again. Bring down your 4x squared plus 9, and this one becomes 2x minus 3 and 2x plus 3. So that difference of two squares is really important to remember that pattern. We square root both and make it plus and minus. Our next one, we can do the same thing, write them as squares. So the first one is 9a squared minus 16 squared. So we can write this as 9a squared plus 16 and 9a squared minus 16. Once again, we have the difference of two squares right here. So we can use that pattern again. Bring down the 9a squared plus 16, and then factor this one out, which is 3a plus 4 and 3a minus 4. And we've completely factored that polynomial.